Okay, so for problem number 5, hopefully you've already watched the part 1 video. Problem number 5, you should be able to solve this on your own, just from what you learned in the part 1 video. But in general, we've got outcome, and sometimes we'll want a description of the outcome. And then we want the probability of getting that outcome. And then we multiply outcome times probability, outcome times the likelihood or probability of getting that outcome. And that's what we add up. We add up this column to get the expected value. All right? So the first possible outcome would be you get a gold marble. Okay? So that's the description of the outcome. Now, what is the actual outcome? When I write outcome, we want the value of the outcome. Like, how much is it worth? Okay, the payoff. So how much do I earn? Okay, so if you get a gold marble, let's see, what do we win? Well, if it's gold, you win $3. Okay, so we collect $3. Are we paying anything to play the game? Okay, so you randomly select a marble from the bag. If it's gold, you win 3. If it's silver, you win 2. If it's a black, you lose 1. So it looks like you don't have to pay anything. It's just that you could lose some money if you get a certain outcome. All right, so we don't have to subtract off like a pay amount that we have to pay. So our outcome is strictly, if you get a gold marble, hey, $3. All right, what's the probability? Well, I've got 3 gold marbles out of how many marbles? There's 3 gold, there's 8 silver, that's 11 marbles, plus 28 black marbles, so 11 and 28 is what, 39? Okay, so so there's 3 gold marbles out of a possible 3 plus 8 is 11, plus 28 is 39 marbles. Okay, so 3 out of 39. So if I do outcome times probability, 3 over 1 times 3 over 39, I'm getting 9 over 39. Okay, so this is the contribution to the expected value if you get the gold. Okay, now what if you get a silver marble? What if you get a black marble? Okay, you should be able to fill these in. Don't forget, for the black marble, you're going to lose, so that's negative $1, right? Okay, silver, you're going to gain $2, etc. Okay, so you should be able to fill in these remaining values, and then you take these numbers right here that you get and add them up, and that's going to be your expected value. Okay, just like before. So you should be able to do this pretty straightforward. Okay. So in this one, yeah, it should be a pretty straightforward problem for everyone. Notice, just to make sure that you did your probabilities correctly, you should always check that your probabilities add up to 1, which in this case meaning it would add up to, in my case, 39 out of 39, or 1, just to make sure that you've got all your probabilities correct. If they don't add up to 1, it means you either left off an outcome or you've added your probabilities incorrectly. Okay? All right, cool. Okay, this is problem number 6, and again, it's a fairly straightforward problem. We're going to have a description of the outcome, then the actual value of the outcome, and then we'll have a column for the probability of getting that outcome, and then finally we're going to do the value times the probability, or outcome times probability. And that's the column that we're going to add up to get the expected value. Okay, so my first possibility would be that you have a faulty item. The other possibility is it's not faulty. Okay, so now if you do get a faulty gadget, what happens? You make a $4, if it's not faulty, if it's working, that means not faulty, you make a $4 profit. So the value is going to be $4. Okay. What if you have a faulty item? You lose $80 for a faulty gadget. Okay, so minus 80. And then what are the probabilities? Well, I know what the faulties are, right? 3 out of 100. Do I know what the non-faulties are? I'll leave that up to you. Notice that it has to total out to 100 over 100, or 1, so that I know that I've got all the numbers. You know, I have to account for 100% or 1.0 in terms of probability. Okay? So you have to deduce what the probability of not faulty is. And then, of course, you're going to just multiply across and add up, and that's going to be your expected value. Okay, I'll leave that up to you. You're going to multiply the outcome times the probability in each case to get this number, right? You're going to add these up, and that's your expected value for the entire situation. If that expected value is positive, you're making a profit. If it's negative, it means you're making a loss on average. Okay? All right, there we go. So let's go on to the next one. Okay, so we're on number 7 here. And so in this case, again, we're going to have a description of the outcome, then the value of the outcome, and then the probability of getting that outcome, and then the outcome or value times the probability. And that's the column that we add up to get the expected value. So what are the descriptions? You can get a green, you can land on a green slice on the wheel. You can do red, and you can do black, and I guess that's it, right? 3 colors. There's 8. So then now you should be able to fill in the rest of this. The value. Remember, to do the value, you've got to have the payoff, which is positive money to you, right? But then you have to subtract off the $3. So for example, for the green, you win $2, but you're paying $3. So the overall result is minus $1. Okay, that's what we're going to use. That result is what we use. What's the probability? I'll leave that up to you guys. Okay, and then you're just going to multiply outcome times probability. So I'll leave you up to, I'll let you guys do the probability, and then you're just going to multiply outcome times probability. Okay, and the same thing here. You're going to kind of compute, and then we're going to add these up, and that total is my expected value. And it's pretty straightforward. Okay, that's it. Now, that's the expected value for one play, for one round, or one play of the game. In this case, they want to know what is it if you play 10 times. So if this is the expected value for one play, for 10 times, for 10 plays, you just multiply by 10. Multiply the one play value by 10, right, to get the 10 play value. Okay, so take this answer, and that's for one round, multiply it by 10 to get 10 rounds. Not bad, right? Not too bad? Just one bad? There you go. Okay, let's go to number 8. Okay, so we're on number 8 here. And for number 8, we're playing roulette. And so there's 18 red compartments, there's 18 black compartments, and then there's 2 compartments that are like what they're called the house's compartments. You can't win with those. Okay, that's so that overall the casino is going to end up making money on every round on average. Okay, but so suppose I wager $8 on red. Well, what can happen? Again, we're going to have description. Then the outcome, the value of the outcome. How much is it worth to us money-wise? And then the probability of getting that outcome. And then we want to multiply the outcome itself, or the value of the outcome, times the probability of getting that outcome. And that's what we're after. That column gives us our expected value if we add that up. Okay? So in this case, you could land on red. If you land on red, what happens? You've bet $8, so you're going to win 8. You're going to get your $8 bet back, and then get an additional $8. Okay. So that means you're going to win $8. What's the probability of that happening? Well, how many red compartments are there? There's 18, but how many total compartments? 18 plus 18 is 36, plus another 2 is 38. Okay? And so your outcome times your probability is this. Okay, and of course I could reduce that a little bit if I want also. Now, what if you land on something that's not red? Land on a not red cell or whatever, or not red, whatever. I'm not sure what you call them on roulette. I don't gamble, but let's say you land on something that's not red. Okay. How much do you win? Well, actually, you lose $8, right? You lose your bet. What's the probability of that? I'll leave that up to you. And how do you do this? I'll leave that up to you. Okay, and then you just add up this column, and that's going to be your expected value. Notice your expected value should pretty much always end up negative, because you, in general, on average, if you play roulette over and over again, on average, you're going to lose money, a little bit of money each time on average. Sometimes you win, but sometimes you lose, and you end up losing more often than you win. Okay, so on average, you end up losing money. So your expected value from the perspective of the player should be a little bit negative. That's how casinos make their money. Okay, plus they sell you things like drinks and meals and stuff like that too. All right, so let's try our, I guess, the last problem coming up. Okay, so problem number 9 here. It's an interesting problem. Again, we want a description of the outcome, and then the value of the outcome, the payoff, and then the probability of the outcome. And then, of course, we're going to multiply the outcome, or technically its value, times the probability. And this is the column that we add up to get our expected value. So there's really 2 outcomes. Either the plane crashes, or there's no crash. And when I say crashes, we're assuming the person's going to die in the crash. Okay, so crash with the death of the passenger. Now, if that happens, what happens? We're paying out $100,000. That means it's negative $100,000 from the perspective of the company, but we're receiving, I know it sounds silly, but we're receiving $1 from that passenger to buy the policy. Okay, so technically this is going to work out to negative $99,999 if you add those together. Okay, so that is the value to the company. If the plane crashes, we have to pay out $99,999. What's the probability? In this case, 0.42 deaths per million passengers. So it's 0.42 over a million. Now, if you divide that on your calculator, you're going to get 0.42 over a million is going to be 0.0000042. Okay? Actually, your calculator will show you 4.2 e to the negative 7, right, on your calculator if you do this, but that's what it means. It means 4.2 when you move the decimal 7 places to the left. But it's easy enough to divide by a million. You're moving you're taking 0.42 and moving it 6 places over because you're dividing by a million. Okay? And then you can do your outcome times your probability. All right? So that's the first row, crash. Now for no crash, let me just change colors here a little bit, just so we can kind of see it better. For no crash, what's going to happen? For no crash, what do we get? What's the value? Well, we just receive $1 as the company, a whole big $1, right? What's the probability? Well, it's just going to be 100% or 1 take away the 0.0000042, because the 2 outcomes, this probability and this probability, have to add to 1, or 100%. Okay, which is 1 in decimal form. And so you can always, if there's only 2 once you know the probability of one set of outcomes, you can get the remaining probability by just subtracting from 1. Okay, and then of course we're just going to multiply outcome times probability and add those up, and we're going to get the expected value for one policy. Now hopefully that's positive. It should be a positive value because the company's in business to make money. If it turns out negative, you probably did something wrong, because that means the company loses money on each policy. Okay, so it should turn out positive. It should turn out be a positive number less than $1. It should be something in the cents range, because you can't make more money than you're charging for the policy. Okay, so it should be something between 0 cents and 100 cents, somewhere in that range. Okay, and that's per one policy. But then they want to know, what if you sell 60,000 policies? So then you just take this result and multiply by how much? Multiply by whatever number of policies. Okay, so in my case, I would multiply by 60,000 to get the total payoff. Okay, easy peasy. It's just the numbers are a bit crazy here because you're dealing with very small probabilities. Okay, so if one of them is a very small probability, the other one's a very large probability. So that means decimals become a real issue. So you have to be careful with your decimals. Other than that, it's a pretty straightforward problem. Okay, and that's that. Not too bad, right? Just one bad, maybe 1.5. That's not bad. And that's it.